Welcome to today's session. Uh, so you might know about galvanized test prep already, right? Just a quick introduction, right? We help, with end-to-end personalized solutions for students and working professionals who are aspiring to study abroad, right? Especially in countries like US, UK, Canada, right, and many of the other destinations. And we have everything from personalized test prep, admissions counseling, and we also have we provide matching with education loan providers and stuff like that, right? So we provide end-to-end solutions for all your needs. So that is what the company does, right? And we've had people from multiple countries who have joined with Galvanize and pursued their higher ed journey. And today's session going to be hosted by me. So I'm Sriram, and I'm the Chief Learning Architect here at Galvanize Test Prep. And my background is primarily from teaching, right? So I did my BTech at IIT Madras. I went to the US for a PhD, but I did not complete my PhD because I was more passionate about teaching. So I quit my PhD, I came back, and I have been coaching students for multiple exams, right? So SAT, GRE, IIT JEE, even for younger kids for Olympiads, stuff like that. And at Galvanized Test Prep, my role is about designing the pedagogy, and I ensure that the product as a whole, is designed with the best quality and with the right pedagogy, so that our students can benefit from the product, right? So that's my goal. That's my role over here at Galvanized Test Prep. Okay, so with that introduction, let's get started, right? And I'm just going to give a very quick overview of the quantitative reasoning section on the GRE. Many of you might have attended last week's session where we probably went through this in a lot more detail. So as far as the quantitative section is concerned, there are actually two sections that you would get, and you might get an optional third section, right, which may or may not appear. But typically, you're going to get two sections in quant, and each section is going to be for 35 minutes, and you're going to have 20 questions each, right? And based on your performance on these two sections, you would be given a scaled score that lies in the range between 130 to 170, right? So 130 is like the bare minimum, that's equivalent to 0 percentile, and 170 is the maximum that you can get on the test, right? So that's a quick overview of how the quant part of the GRE is structured. And in terms of the question types, you have different kinds of questions. So you might have come across what you have probably heard as quantitative comparison, right? So quantitative comparison is probably something that is unique to the GRE, where you have two quantities, quantity A and B, and you're asked to determine the nature of the relationship between those two quantities, right? Whether quantity A is bigger or quantity B is bigger, or the two quantities are equal. Or there's a fourth option, which is there is not enough information to determine the nature of the relation, right? So those are always the four options. So the quantitative comparison question would always look like that. It is like an MCQ, but it's of a slightly different structure, right? And you have multiple choice questions where you could have multiple choice questions with one correct answer, or there could also be questions which have one or more correct answers, right? And then you also have something called numeric entry questions. So numeric entry questions are questions where you're expected to write the answer, type in your answer either as a decimal or as a fraction. If it's given as a fraction, they would usually give you two boxes, one for the numerator, one for the denominator. Okay, so that is just quick summary about the question types that you would encounter on the quantitative reasoning section, right? And roughly around 60 to 70% of the questions will end up being either multiple choice with one answer correct or quantitative comparison, right? So that's broadly what you would see on the uh, test. Okay. Uh, any questions about this? Okay. So today's session is going to be on something very specific. Okay. Uh, so we are going to now focus on how to approach problem solving in GRE Quant. Okay. Now I have put the word GRE Quant over there, but this is not really true. This is not necessarily just for GRE Quant. This can be applied actually in any context. Okay. So I'm going to teach you the art of problem solving, and I hope that you find this useful in everything that you do, not just in the context of GRE. Okay. So what is really the problem, right? I know a lot of our students who come and say some of the things that I mentioned over here, right? I'm very confident in most topics in math, but I get stuck while answering a problem, especially word problems, right? Now, this is not just true in GRE. This could be true anywhere, right? I know a lot of people who prepare for aptitude exams, any exam that has an aptitude component to it, right? Uh, they have these kind of problems. Given enough time, I can solve all the questions accurately, but handling the time pressure during the exam is something that I struggle with, right? A lot of people ask me, how do I solve this question faster? Okay. Another huge, category is the careless errors that people do while solving problems, right? So, do you relate to some of these? Yeah. Are these things that you would have felt at any point to whenever you try to prepare for any exam, not just for the GRE? Does this resonate with you guys? Okay, so so today's session is going to be focused on uh, how to overcome some of these problems, right? How do we get better at problem solving? Okay, so let's try solving a problem. Okay, let's see how it works. Let's first take a problem and let's just dive right into it. Okay, so here is a question. Okay, I want you to look at this question and take a minute and tell me what you think is the correct answer. Okay, we have one answer, 111. Anyone else? Okay, there is somebody who said 300. And there's also D, another 111. Okay, okay, change your answer to E. None of these. If you think it's none of these, can you tell me what is the answer? Okay, so so someone has answered 300, Avinash. Uh, great job. You're right. 300 is indeed correct. Okay. So how would you go about actually answering this question? Okay. Now, one way to do that is uh, let's not look at the answer choices. Let's just try to figure out how many times the digit 9 will appear when listing numbers from 1 to 1000. Okay. Now, the brute force way to solve this would be to actually count the number of times the digit 9 occurs in one digit numbers, two digit numbers, and three digit numbers. Right? So I'm going to just do it brute force, which means that I'm actually going to list out all of them, but I'm just going to try and do it in a more structured manner so that I don't miss anything. Right? So let's just look at the number of times 9 appears in one digit numbers. Right? It's just going to appear once, the number 9. Okay. But what happens in two digit numbers? Now, in the two digit numbers, 9 could either appear in the units place or in the tens place, right? So the numbers could either be in the form like this, which is 9 in the units place. So something 9, right? And there are 9 such numbers. So the tens digit can be anything from 1 to 9. So 19, 29, 39. In all these cases, that is in 9 of these numbers, I would be writing the digit 9 in the units place. Okay. Similarly, now I'm going to count how many times 9 can come in the tens place. Right? It's going to come 10 times. Why? Because now the numbers are of the form 9 and blank. And the blank can also take the value 0 now. Right? I can form the number 90. Okay, so from 90 to 99, there are 10 numbers where the number 9 appears in the tens place. So totally, that's 19 times I'm going to write the digit 9 when I'm writing the two digit numbers, right? And if you were to do this methodically for three digit numbers, you would see that it's actually 90 plus 90 plus 100, right? So numbers of the form 9 blank blank or blank 9 blank or blank blank 9, right? So in the case where it's 9 blank blank, where 9 is in the hundreds place, now the other two can be, there'll be 10 options for each of the two places, that is the units place and the tens place. So that's why you have the 100. The other two cases, it's going to be 90. Right, where 9 is in the tens place or 9 is in the units place. So totally, you're going to have 280 times the 9 appearing in three digit numbers. So if you were to add all of them, so the answer is 19, 1 plus 19 plus 280, which is equal to 300. Yeah. So is this clear? Is this a simple solution? Yeah, no doubts about this. Okay. Now, the question is there a way to do this faster? Right? Because think about it. This is the brute force approach, and there's a lot of possibility for making mistakes. Right? You miss something. You miss a count somewhere. You're going to totally mess up your final answer. Right? So this is fine, it works, but it's error prone and it's very long, right? It's very time consuming. Okay. Now, is there a smarter way to do this? Okay. Now, for that, I'm going to suggest an alternate approach. Okay. And the way I'm going to do this is I'm not going to take this list, but I'm going to take a slightly different list. Okay. The idea is to exploit the symmetry in the problem, right? The number of nines in this list should be the same as the number of fives, right? There should be no difference. The number of fives should also turn out to be 300. Okay, so there seems to be some kind of symmetry, but there is one number alone, right? Which is the number 0, which is going to be a little different because I don't write leading zeros. right? So I don't write 1 as 0001, correct? So if I were to take the number of zeros alone, then this symmetry, would not be applicable. Okay. So what I'm going to try and do is, can I make it symmetric with zero as well? What about if I were to consider uh, a list like this, right? Think of them as 3-digit strings. Okay. So I'm starting from 000, 001, 002. So I'm going, top to bottom, and then to the second column, top to bottom. I'm going all the way around until I reach 999. Right? Now, how many numbers are there in this list? 3,000 numbers, right? Okay. Now, would the number of nines in this list be any different from the number of nines in the list that is given in the question? No reason, right? Because the number of nines has to be the same in this list as well as what is given in the question. So if I find the number of nines in this list, then I'm done. Does that make sense? Okay. But the number of nines in this list is actually very simple to calculate. Why? Because there are totally 3,000 digits, right? Because there are 1,000 numbers, and each of them I'm writing as a 3-digit string. So totally I'm writing out 3,000 digits, and the number of times 9 would appear is the same as any other number, right? So 3,000 divided by 10 has to be 300. Right? Now, my point is that in this symmetric list, each digit will appear an equal number of times, and therefore 9 would appear 300 times. But the number of times 9 appears in this list is same as what is asked in the question, and therefore the answer to the question should also be 300 times. So if you notice, what did we do here? We took a more symmetric list and we didn't have to do any counting at all, right? It's very easy to see that there are 1,000 numbers and each number is written as a 3-digit string. So there are totally 3,000 digits. So if at all, the only calculation that I'm doing is I'm doing 3,000 divided by 10. Make sense? So the idea is that by taking an approach which is, which is more accurate, that is, in this case, it's less error prone and significantly shorter, we have a much higher chance of getting the right answer. One, two, the time that we save on this question is time that we can spend on some other question, right? So in that context, right, choosing the right strategy to solve is, can make a huge difference when you're solving problems in a timed environment. Does that make sense? Yeah. Okay. So the correct answer to this question is indeed 300. So this is probably something that's there on your head, mind right now. You're probably thinking, okay, in this particular question, fine, we were able to do this. Seems quite easy. But how do we extrapolate this, or how do we, take this idea and how do we do it on a different problem? Right? Because each problem is going to be different and has its own strategy. You can't apply the same strategy on some other question and expect it to work. Right? So is there something that we can learn that we can apply on any problem? So that is what we call at Galvanize as the problem solving strategy. Okay. What is this problem solving strategy? I'm going to try and break this down. Okay. It's actually a very simple idea. It's an abstract way of looking at problem solving. Okay. And this is actually applicable for any kind of problem that you encounter, right? Not even just a mathematics problem. It could be something, with respect to your research or with respect to something that you're doing in your undergrad, right? It could be anything, right? So whenever you're looking at whenever you're trying to solve a problem, you start with a series of steps, right? You're going to follow these steps, okay? And you want to start with defining the problem, right? That's the first step. You're going to try and understand what is the problem that you're actually trying to solve, right? Define it in a manner that it's clear. Now, once you've defined the problem, now you're going to think about the problem, right? Is there anything that I already know or any concept that I've already learned which is related to this problem? Is there something that I can apply? Okay, so this thinking about the problem, I'll elaborate a little bit more about it. Now, once I've thought about the problem, I'm going to try and plan a solution. I'm going to come up with a strategy, right? Now, once I've planned the solution, the next step is to execute the solution, right? Now, then I look back at step one to see if I have actually answered the problem, right? So I'm going to look back at the definition and see if my answer actually makes sense. If it is successful, then I'm done. If not, I might have to go back to the loop again to any of these steps, right? So these steps might seem a little abstract at first, but let's try to understand each of these steps a little bit more, right? And let's try to explain what is it that we're looking for when you're doing these steps in the context of solving a problem in a test, right? So the first step is to define the problem, right? Now here, the goal is to understand what is asked in the question and state it in a way that is more clear to you. Okay, that's the entire goal of this step. The understanding of the problem is usually half the battle. If you understand what is given in the question, and if you're able to, so look at what are the knowns, what are the unknowns. If you can use some kind of a visualization, right, that would help you, greatly, right? For example, putting that simple, grid of numbers helped us to see that, the pattern is actually very simple, and there are 1,000 numbers. Yeah. Um, Watch out for any units given for the quantities. Okay, that might actually give you a clue about how to frame the equation or any of those things. And explicitly write out what is the criteria for success. What is the nature of the answer that you're looking for, right? So sometimes in the context of GRE, you're only looking to compare two quantities, not to actually evaluate them, right? You're just trying to establish the nature of the inequality. Sometimes you're not even asked to find the value, right? So just because they are unknowns, you don't have to find the unknowns. You just have to find the relationship between the unknowns. So like that, for each question, you have to look at what is the criteria for success, right? The second step is to think about the problem. Okay, are there any specific concepts? Is there something that I've already learned which will help me solve this problem, right? Do you know how to connect them, right? So let's say, for example, you see a triangle. Maybe your mind goes to see, okay, this is a right triangle. Can I use Pythagoras theorem here somewhere, right? That's how you're going to think about the problem, right? And this is also the step where you're going to think about whether you can actually solve this problem or not. Sometimes it might be better to decide that, you know what, this question is too hard for me, or this question is on a topic that I don't know enough about. So I'm going to come back to this later and focus your time on some other question that you know how to solve, or you know for sure that you can actually get it right. Right? So thinking about the problem is an extremely critical step, okay, where you uh, look at all these things, right? Do you look at the concepts that you know already? You're going to see how you can connect them. And you're also going to take the decision whether you're actually going to solve the problem, or you know what, I'll come back to this question later, right? So that decision is also going to be taken when you're thinking about the problem. Okay. The next step is to come up with a solution, right? There are going to be various strategies that may be suitable for the question, right? You can have some very typical problem solving strategies, right? Compute, simplify, use an equation. Sometimes you're going to work backwards, you're going to look at the answer choices and come back to the answer, right? So there could be multiple problem solving strategies, okay? But the goal is to try and identify the one that will give you the answer accurately and in the shortest possible time, right? So you're not just looking for speed, you're also looking for something that will get you the answer accurately, right? So for example, in the the first approach that we took for the problem, uh, the method was not wrong, right? But there is just a scope for a lot of uh, careless mistakes, right? So the more calculations that you have to do, more chances for making some careless mistakes, right? So you're always better off choosing one where you're choosing a strategy where you have to do a minimum number of calculations, right? And that will naturally be one of the shortest uh, ways to get to the answer as well, most likely, right? So the goal is to try and identify a strategy that will get you the answer accurately and in the shortest possible time. Okay. Now, the fourth step is actually executing the strategy. Now, usually this is the easiest step, right? Because you have thought about the problem, you have come up with a strategy, you know everything that needs to be done, and you're just going to mechanically work this out, right? You're just going to blindly follow the plan. So if you have a good understanding of your strategy and your concepts, then you should be able to do this step easily, right? But this is one step where you could make a lot of these mistakes. Like you could make some unstated assumptions, which means that you didn't define your problem properly, or you might make some calculation mistakes, right? So the goal is to try and work quickly but carefully. You're better off working it out once and getting it right, okay, as opposed to doing it very quickly and figuring out that you made a mistake and then coming back and doing it again, right? So work quickly but carefully, right? Don't be in haste. Okay. And the final step is to uh, check whether the answer actually makes sense. Okay. And you're also going to ask the question, is the question completely answered? Right? Sometimes people stop with, they usually name some variable as X, and the moment they find X, they'll stop there. But the problem might actually be asking for X plus Y. We don't know that, right? So unless we have understood what is asked in the question and we have explicitly written that down, okay, you won't be able to check whether you've gotten the right answer or not, right? So it's important. This goes back to step one, where you should have defined your success criteria correctly, right? So once you have the success criteria, now all that you need to check is whether the question, whether the answer that you've come up with actually satisfies those success criteria, right? Now, during the prep period, right? So I'm not talking about doing this on the test, right? But during the prep period, you should always think, if I have done this problem, could I have done it in any other way? Could I have done it, in some other method which would have given me the answer faster? Okay. Sometimes you might also want to learn what you got from this question, because that learning might be applicable for some other question, right? So during the prep period, we always advise our students to also just take a moment to think about, uh, you know, could they have taken, because right now, that particular step, right, where you've just executed the solution and got the answer, you might get this moment of like, oh my God, if I had done it the other way, I would have gotten this answer so much faster, right? And getting it at that time will stay in your memory for a much, much longer time, right? It is much better than, someone else coming and telling you, hey, you know what, you could have done this in another way, right? You realizing it for yourself is one of the best ways to learn. Make sense? So during the prep period, we advise our students to ensure that, you also think about how you could have done this problem in any other way, and also think about what you learned from this problem. Okay? So far, so good? Any questions? I'm pretty sure that many of you are probably thinking, okay, all that was really vague. Okay, how does this really work? Okay, all this abstraction about these 5 steps, and nobody's really doing that, right? You're not actually thinking about, okay, now I'm going to define the problem. Oh, now I'm going to think about the problem. We don't really do that in our head when we actually solve the problem, right? So how does it actually work? Now, the reason why I spent some time to demonstrate those 5 steps is because I want you guys to understand what are all the processes that are involved, right? You may not be doing each of these steps consciously, but every time you solve a problem, at some level, you are doing these steps. Okay. Now, the idea is to try and figure out, how you look at each of those steps, okay, and understand the value of those steps so that you can ensure that you do that when you solve the problem. What do I mean by that? Let's try to apply the problem solving strategy. Okay, let's take a problem and apply the strategy. Okay, so let's look at another problem. So here is a question which is a numeric entry question, right? So you're supposed to enter a number as the answer. Okay, so it's a pretty simple question. Okay, it's not very hard, but I'm going to work with you and explain to you how you're going to get this by applying a strategy. Okay, so I have not chosen a very hard problem to demonstrate this. I just wanted to take something simple, but I want to show how you can use these steps effectively to get to the answer correctly, right? Okay, now let's read the question once, and we will dive right into solving the problem. Okay, a committee has 14 engineers and 30 non-engineers. The number of women who are non-engineers is 10 greater than the number of women who are engineers. If a third of the men in the committee are engineers, then how many women are there in the committee? Okay, that's a simple word problem, yes, but there's a lot of text that's going on. Okay, there's too much text, and it's a little hard for me to process, right? So I know a lot of students, typically complain with word problems is that it's too wordy, right? That's the whole point. And when you're having word problems like this, what we suggest is to try and break down the word problem into different parts, okay, and look for the information in each of the parts and see if how you can extract them or make a connection between them. Okay. We usually also suggest people to represent the information in some simple format so that you don't have to keep going back to the question. Okay. So here is how I would do this problem, right? I'm going to understand this problem better. So I'm going to first put out a table, something like this, right? Now it's actually very easy for me to see that there are actually, 2 categories, engineers and non-engineers, and there are 2 genders, men and women, right? I'm going to look at the people in each of these categories, the number in each of these categories. Okay, so a committee has 14 engineers and 30 non-engineers. So that information is given to me, right? I'm just going to fill that in the table. So as and when I read the sentence, I'm going to fill up the table. Okay. Now the second thing is that the number of women who are non-engineers is 10 greater than the number of women who are engineers, right? So one way to do this is I'm just going to introduce some variable. I'm going to call that as, say, let the number of women who are engineers be X, and the non-engineers is X plus 10, right? Now, before I go to that, I just want to notice that the total should add up, right? The total number of people has to be the total number of uh, engineers plus non-engineers. There are totally 44 people in the committee, right? Now, out of that, there are X women who are engineers, and therefore there are X plus 10 women who are non-engineers. Okay, that's from my second statement, right? Now I'm going to look at the last part of the sentence of the word problem, which is if a third of the men in the committee are engineers, then how many women are there in the committee, right? So that's what is asked. 2x plus 10 is the total number of women. And let's say there are totally 3y engineers, sorry, 3y men, then one third of them are engineers, right? So that's the last piece of information that is given to me. And the question is asking for what is the value of 2x plus 10. Make sense? Right. So it's actually very simple to see that we can form two linear equations in x and y. Why? Because y and x should add up to 14 and 3y and 2x plus 10 should add up to 44. So we have two equations in two variables which we can solve to find x and y. So that is my strategy, right? So think about what I did. I defined the problem, I thought about it, and I realized that, you know what, I can form two linear equations. So I just noticed that if I add these two, I'm going to get 14. If I add these two, I'm going to get 44. So I can frame two equations and I can solve them. So now let's execute the solution, right? So we're given these two equations. So I'm going to subtract twice the first equation to the second equation. So I get 3y plus 2x plus 10 minus 3y plus 3x equals 44 minus 42. All right. So I'm just doing a little bit of algebra over here, and I'm finding out x equals 8. And if x equals 8, y equals 6. Okay. So are we done? Not really. Right? Because the question asked me to find 2x plus 10. Right? So now I have gotten x. 2x plus 10 is 26. Right? So I'm just going to do a very quick check. Right? I'm going to fill in all the values in the table to make sure that our answer is actually correct. So if I were to fill it, this is what I would get. Right? There would be 6 men and totally 18 men. So that is indeed one third. And I would get 8 women who are engineers and 18 women who are non-engineers, and the difference is 10. Right? So these numbers work, right? And the answer to the question is 26. Okay, so, and that's how I would solve this question. Now, again, there might be a few of you who are probably thinking, how do we do this on the test? That took a really long time, right? The way we broke it down and wrote that table and framed the equations. And I'm sure that you guys are probably wondering, hey, you know what? That's not going to be fast at all, right? On the test, is actually going to take more time. Okay, so I want you to remember that this is the first time we're doing this. So I kind of explained it to you step by step. But on the actual test, you would be able to do this much faster if you get used to it. Okay, so let's analyze this problem solving strategy that we came up with uh, a little bit more. Okay, so I'm going to go back to our steps. So these are the steps that we laid out, right? This makes sense at a very high level. The only problem that we seem to have was, how do we do this quickly, right? Now, before I go into that, I want you to notice that uh, some of these steps are a little similar than some of the other steps, right? I'm actually going to divide them into 3 categories. Okay, so I'm going to call them as, the first category is the realm of knowledge, and this one is the realm of skills, and the realm of execution. Okay, so now if you were to look at the realm of skills, right? So defining the problem is a skill. Identifying a strategy for a question is another skill, right? Thinking about the problem, looking at what concepts you have, making the connection. Now that is about your background knowledge, right? So what do you already know? That's in the realm of knowledge. Am I making sense? And the last one is actually the realm of execution, where you're actually working out things, right? And looking back at step 1, that is what is going to help you to, stop doing those careless mistakes, because you're going to come check your answer against what is given in the question once, and you're going to you're going to actually find out if something went wrong, right? So we actually have these three realms where you're going to have some skills, and there is knowledge, and then there is actual execution. Now, what about the realm of skills? So how do you get better at the realm of skills? So how do you build any skill for that matter? Now, if you take something like, say, riding a bicycle, yeah, that's a skill. Okay, how do you build that skill? How do you learn how to ride a bicycle? You don't go through, some YouTube videos which explain how to go through how to ride a cycle. You don't take out a book and learn the various concepts of how to balance a cycle. You're not trying to understand the physics behind balancing a cycle. You're not doing all that, right? So what do? You just take a cycle and start riding it, right? You might fall a few times, the first few times, but you will be very slow to begin with, right? You might make some mistakes, but slowly, as you keep practicing, as you keep cycling, you're going to get better and better at it. And at one point, you would be able to start cycling without even thinking about cycling, right? You never, when you're actually, you've learned how to cycle, you're not thinking, oh, you know what? I have to now tilt slightly to the right because I'm falling the other way. You're not thinking all that, right? You just know how intuitively, you know how to balance. Why? Because you've learned how to cycle. Okay. So both coming up with the definition of the problem and coming up with a strategy are skills that you build by practicing a lot over time, right? So they're very different from gathering knowledge, right? You can gather knowledge, on the night before the exam by studying, if it is a knowledge-based exam. You can't do that for a skill-based exam, right? So imagine if you had to, if you had a keyboard class or a piano lesson, right? And they had a piano test. You're not going to be able to, master playing the piano on the night before the exam, right? You need to keep practicing at regular intervals over a lot of time to get better at playing the piano, right? So learning any skill is very similar, right? You do that by doing, getting a lot of practice. The realm of knowledge, on the other hand, is learned by, you start with understanding the basics and then you build on top in a structured manner, right? And the last one is the realm of execution. This is usually the easiest part. If you've done the realm of skills and if you have good knowledge in already gathered, then execution is usually the easiest part, right? Now you need to be careful, right? So in the realm of execution, what is important is to be meticulous and consistent, right? You have to keep doing it in a methodical manner, right? That's all there is to it. So I want you to remember this, right? So if you found that this particular strategy was uh, very abstract, then I tried to break it down to you and I used an example to show how we can actually do it. But then the way I did it, it seems like, it'll take a lot of time, right? And you have to trust me on this because we worked with a lot of students. And as you keep practicing this, as you, sharpen your skills, you would get much, much better at solving these questions way faster and also extremely accurately, right? Why? Because you're now doing this in a very structured manner. You're not reading the question again multiple times. You're not you're not misreading something or making an assumption. You're not doing all those things. You're first focusing on defining the problem, and then you're thinking about the problem, and then you're coming up with a strategy, then you're executing it, and then you're checking your answer again, right? So this cycle is something that you would get. It's like, even in the middle of the night, if I were to wake you up and ask you to solve, you would start doing that approach, right? So that's how it works after you have practiced this multiple times, right? Over a lot of period. right? So far so good. Any questions on this so far? Does this make sense, that whatever I said? Okay, so just to finally summarize, right? Learning concepts have to be coupled with practice, right? You can't just learn concepts and not practice them, because by learning concepts, you're only building knowledge. You need those other two skills as well, and you get better at those skills only with practice, right? So you need adequate, skill-oriented, timely practice. And this is something that we keep, we believe a lot, right? We don't just teach a person how to fish, right? That's what we need to do. We need to teach how to fish, and not just keep feeding them fish. Okay, so that's what we do at Galvanize, and we have multiple courses open, right, for GRE itself, based on whatever you're looking for, how much ever time you have left for the exam. And we also help with admissions counseling. And everybody who's attended this webinar, you're free to collect a exclusive discount. Do get in touch with us. Okay, you can reach out to galvanizeandtrain.com, or the phone number that is mentioned over here. Okay, and we have multiple extremely high quality people who work with applications as well. We have Pavitra, who's did a master's from Stanford, who's also the founder of this company. Myself, I'm from IIT Madras. You have Soumya, who did her master's in the US. Divya, who heads our global admissions, she's a PhD from University of New Mexico. And Rohini Venkatesh, who's our one of our customer support course managers. Jayanti is again another PhD. So you will find that you're all people who have at some level gone there, gone to the US or any other country. You've achieved something at a higher education level, and our goal is to try and help students to get to that next level, right? So that's I want to stop with this, right? So you can please reach out to us if if you have any questions. You can use any of our social media or email, or you can use a phone number to get in touch with us. Okay, I'm happy to stay for a few more minutes and answer any questions that you guys have. Uh, we can wrap up otherwise. Okay. Um, Thanks a lot. Thanks a lot for all your time, and I hope